All right, I'm making this video to help with kids who are struggling maybe with understanding square roots and their connection to, uh, in particular, their connection to uh, solving equations. So I'm going to kind of go right back to the beginning and explain square roots so that people understand what it means. And I think you all know the symbol for a square root looks something like this. So um, we're gonna use that a few times. And so just bringing my laptop in a little closer so I can get to the screen because I'm just going to do this writing on the screen. So one of the things, like, I'll take a number like 5 and let's just pretend we go 5 squared. And I think most students understand that this means 5 times 5, which equals 25. Okay, and just like multiplication, we can use division to kind of go backwards, which is the sort of opposite operation. Square root is essentially the opposite operation of a square, squaring something. So it removes the square. And to explain this better, I'll just say, pretend that we took the number 25 and we're going to take the square root of it. Well, what it really means is I can change this into 5 times 5 under the square root sign. And the square root sign will then remove one of the 5's and we cancel it off and we end up with the answer 5. And I think most people get that. Now, there is a unique feature associated with that, in that the answer to the square root of 5 could also be minus 5. And that reason being, I'm going to say or minus 5. And the reason is that 5 times 5 equals 25 and minus 5 times minus 5 equals 25. And so when we're taking the square root of a number, we're looking for any two numbers that will multiply, or any number, sorry, one number that will multiply by itself. So multiply, square it, and we would get the answer of 25. And that's the answer we're looking for. So either of these two answers actually work. That's where the plus and the minus kind of come into play. And so we just kind of get into the habit of saying the square root of 25 equals plus or minus 5. It can be either, and we write it that way. Mathematicians, as I've said in the past, are notoriously lazy. They don't like to have to write more than they have to, and so they come up with these creative little shortcuts to do that. All right. Now, I'm going to go continue on and use a bit more of this page by scrolling down a little bit here and talk to you about it in the terms of, variables. Okay. So when we start talking about variables, we'll say things like, x squared. Well, we can take the square root of x squared. And when we take the square root, I'll just make sure that's hat there is on there good. It really means the square root of x times x, and hence that equals, oops, not 5, but x. Sorry, I just have to erase that. I make mistakes. Equals x, okay? Just like we did when we did 5. And so that, essentially is how it operates. Now, sometimes students will run into a question where they have a question that says like something like this, where it's like 2x squared, right? And they want to take the square root of that. Well, you cannot do this, because if you had to do it, it just won't work, because we cannot take the square root of 2. The square root of 2 is some weird number. It's like 1.41 and goes on and on and on and on. It's not what we call a perfect square. Okay, so we cannot do this kind of question. We have to get rid of the 2 in front of the x squared to do that. Okay, so I won't give you questions that look like that where you have to do that, or you have to address the 2 in front. You have to get rid of it before you can do it. So sometimes I'll have a question like, you might get, go back to my line here. You could say 2x squared equals, let's say it equals 8. Well, I can solve this, but I have to get rid of the 2 in front of the x squared. So what do? I divide both sides by 2, okay? And I get x squared equals 4. And now I say, let's take the square root of x squared. Let's take the square root of 4. Well, the square root of x squared, as I showed up here, is simply x. And the square root of 4 is any number that when multiplied by itself will give me 4. Well, what number when we multiply it by itself gives me 4, or in other words, square it. Well, that would be 2. And because of the nature of things, it can be also minus 2. So we often just write it as plus or minus 2. Okay. And it's really important that you isolate only what is getting squared when we do that. Okay. And you can do this in a variety of different ways too. If you want, for example, you can have a larger thing being squared, but the whole thing has to be squared. So I can say x plus 2 squared equals, well, that essentially equals x plus 2 times x plus 2. So if I square root this, or I square root this, that's the same thing. And over here, I would say I eliminate the squared. Here, I eliminate one of these and the square root, and I end up with x plus 2 in either case equals x plus 2, and it works out just fine. Okay, so that's just an example of how we can square things that are bigger as long as they're in brackets and the whole thing is being squared. Okay, not just something small. Square root's not a real easy concept, but it is something that we can utilize to help us. So I'll give you another example that would work like this. So just erase, sorry, I'm running out of space here, so I'm going to erase a little bit. Oh, this is great. Look at that. I could just erase the chalkboard. It's just like being in the classroom, right? So if I give you a question like, I don't know, let's go back to my pen, make one up, say x minus 3 squared equals, we'll say, 16. I can square root both sides of the equation. How do I do that? Well, I go like this, and I go like this. And the square root of something squared is just it without being squared. So this is x minus 3, which equals 4. But of course, this 4 could be a plus or a minus. Whenever we take the square root of just a number, it can be plus or minus. We don't have to worry about it on this side of the equation, but this side we definitely do. And now I essentially have two equations. I have x minus 3 equals positive 4, and or x minus 3 equals negative 4. And I can solve each of these equations simply by adding 3 to each side. So this one equals x equals 7, or x, we're going to add 3, and x will equal minus 1. And so those are the two possible answers that you can have. And I can actually show you that they actually work. So if I want to, I can take this equation and I can put 7 in there. So I could say, take the original equation, which would be 7 minus 3 squared equals 16. Well, does that work? Well, it's 7 minus 3. That's 4. What's 4 squared? Does that equal? It sure does. It equals 16. And 16 equals 16, we're good. What if I put in minus 1? Instead of putting 7 here, I put minus 1 in. Well, let me just find myself a little space down here at the bottom. And I said to you, bracket minus 1 minus 3 squared equals 16. Well, minus 1 minus another 3 is actually minus 4 squared equals 16. What's minus 4 times minus 4? Oh, look at that, it's 16. So it works in both cases when I put it back into the original equation. Okay, that's just an example of that. Square root's not something easy to work with, but it is something that is a useful tool. And anytime we have something squared, we generally want to go to that system of using the square root. Now, it gets more complicated. What complicates the matter is if we have sometimes a square and we have a trinomial, and you have to recognize the difference here, right? Sometimes we'll give you a question that looks like this, x squared plus, I don't know, 7x plus 12 equals 0. And in this case, I have an x and an x square root to solve it. We use a different technique, right? And so we're able to recognize this and factor it. And so we did factoring in class, and so we realized that this is x plus 4 times x plus 3. And I got that because 4 times 3 equals 12. And when I add them together, I get 7x. There are other factors of 12, like 1 and 12 and 2 and 6, but they don't add to 7. And this equals 0. And then we use this wonderful principle that says if 0 times something will give me 0, that's the only way we can get 0. So therefore, I can set two equations. I can say x plus 4 equals 0, or x plus 3 equals 0, and therefore x equals minus 3 or x equals minus 4. Those are the two numbers that when we put them in there will make that 0. So that is a useful tool. It is not square root, but it helps us get rid of the squares. Hopefully this little mini lesson on square root helps you better understand square root. I don't know, it's not an easy topic, and a lot of kids will sometimes need a little bit of extra help. Hope that helped.